All right, so this one, we have been given a piecewise function, and we want to try to determine what its equation is. And I've already divvied it up into colorful parts for you. And we just want to figure out what's the equation of this one. Each part is going to have its own equation, and then we're just going to put an interval for each one, and we'll be set. I'm going to start with the red one because it's the most complicated, and then they kind of get easier along the way. So that is a quadratic. I can tell because it's U-shaped. So I know it's going to be something squared. I also know that it's going to be moved over. So this thing got moved to the left and it got moved up. If I check my happy function book, moving to the left means I need to add on the inside of my function. So inside of that squared, I'm going to put a +4. And then it's moved up 1. So to move up, I know I need to add on the outside as well. So +1. There is the graph of that one. We'll worry about intervals once we've got all of our equations. I still need to tack on where x should be less than or blah, blah, blah. The blue one is really easy. It is just a flat line. A flat line, if we carried that thing across, it would just be 3, 3, 3, 3, 3, 3, 3, 3, 3. So that's when y is 3 all the time. So that's just going to be a 3. No, not an eraser. I would like a pen. When y is just 3. Next, we have an equation there. We've got a nice slope, a linear equation. It's a straight line for the green part. Yeah, if you put the two together, it almost makes absolute value, but one of them's tilted more than the other one, so it doesn't quite make a perfect V. It doesn't quite make a perfect V. It is not absolute value. So we just want that green part. The green part has a y-intercept down here at -3. What's your slope here, buddy? We're going down 1, 2, 3, 4, 5 over 2. So we've got a slope of 5/2. -3 using good old slope-intercept form. Thanks, slope-intercept form. What about that orange line? That orange line also has a y-intercept of -3. What is your slope, friend? Where is another good point for you? Oh, right here. Okay, so we go up 1, 2, and we go over 1, 2, 3. So we have a slope of 2/3. Now, if anyone was annoyed, I just noticed the green line is going down, so it should have a negative slope, -5/2. Sorry about that. And there we go. There is our equation. The only thing that's missing is those intervals. So if we start with the red one, we seem to start right here at -3, and we are heading that way. So we're heading to the left, and it's got an arrow on the end, so we want to just keep going. So we want our x values to be less than -3. So where x is less than -3. Oh, I got the wrong end. I'm going to throw the equal on there just so I can get the equal out of the way. You can put the equal to on that one or this next one. Now that little blue line, it's stuck between -3 and -2. So let's just stick it between, we want the x values between -3 and -2. And we'll just give them both less thans. If you wanted to make one of those equal to's, that'd be fine. You shouldn't make both of them equal to's. So like an equal to for both the red one and the blue one, because then it's like, well, where do I put -3? It's unclear. Just don't let them overlap like that. Make it so -3 either goes to this one or -3 goes to that one, but it doesn't matter which. Our green line is stuck between, let's see, these two numbers. So it's between -2 and 0. And I'm checking the x values for that. Now at this point, -2, where does it go? Does it go with the blue one or the green one? I haven't made that clear. I'm gonna get a couple equal to's so I can take care of those endpoints. So like, which one should it be? It's the green one. You could have made it into the blue one as well. Doesn't really matter. Finally, we've got all the positive x values, all the values that are bigger than 0. So we'll make that one a not equal to. So we want x to be greater than 0. Now we've got all our intervals to go along with our equations. We still have to identify our domain and our range. So our domain, as we move across this graph from left to right, we see if we got graph above or below ourselves. We've got a whole chunk of graph, we're all set right there. Once it dips down below, we've got the green line, we've got the orange line, then the orange line pops back up and we got graph above us. We are perfectly fine. So our domain, we never have, as we move across our x-axis, there's always graph above or below us. So the domain is all real numbers. If we want to check the y values, we want to check our y-axis for our range. And we want to see, do we got graph to the left or right of us? Oh, if I start down on the bottom, there's no graph down there. Heck, it doesn't start until that little point down at the bottom. As we move up, it seems like we run out of graph, but remember, this orange line keeps going up. This orange line keeps going up, so that'll cover us, and the red line keeps going up. So we're going to be fine as we move up on this thing. So our range is going to be, our lowest point seems to be -3, and we keep going up to infinity. Oops, I put a parentheses there. That's a filled in point. We gave it a nice equal to, so I want to put a bracket on there. If it's filled in, it should get a bracket. Where is this thing going up? So if I check right here, we are moving up as we move across that. Also, that orange piece, that whole thing is going up. That green piece is going down, so that's where we're decreasing. The red piece is also kind of going down to start with. And ooh, we have a place where the graph is constant, right here. That blue piece, our graph is constant, it's flat. So if we talked about where our function is increasing, we are looking at those x values where it is increasing. So it starts at -4, and it keeps going to -3. Then it starts increasing again at our x value of 0 and keeps going to infinity. Again, on those endpoints, you could put brackets or parentheses. I'm not going to come after you about which one you choose. I'm checking mostly those numbers. Where is this thing decreasing? Well, it's decreasing at the very beginning. It started out decreasing and will continue to do so towards negative infinity, but it stops decreasing at -4. It doesn't start decreasing again until we reach the x value of -2, and it decreases until it reaches 0. Finally, we have a constant chunk. We are constant between -3 and -2. We have a little chunk where it's made a nice flat line. And that's it for graphing these piecewise functions. If you would like, you can check out the additional videos where I'll do more examples of the graphing. The graphing causes a lot of trouble. Also, you could jump to the end of those graphing videos to determine like the domain and range. That's usually where people have trouble with these problems, is identifying the domain and range. So you don't have to watch the whole bonus videos. You could just watch the chunks where I'm talking about the domain and range for those functions. Thanks so much for watching. Thanks for watching the bonus videos if you're watching them. And let me know if you have questions. Bye-bye.